Just a minute. So basically a differential equation, I'm just taking the differential equation. After that, the complete statement is there that find y of 1 or maybe find y of 2. Then the options are there. So let's see, okay, what the differential equation we are having, and we will be discussing till finding the solution. After that, you will be able to find y of 1, y of 2, y of pi by 2, y of pi by 3, whatever is asked. Okay, so this is the differential equation dy dx plus 2x square plus 11x plus 13 over x square plus 6x. I mean, here x cube is there. And then 6x square plus 11x plus 6y is equals to x plus 3 by x plus 1. Okay, so this is our differential equation. We have to find the solution first, and then we have to find y of 1. So let's do till solution, how to find the solution over here. Can you see this is also like which type of differential equation we are having? Meera and Upasna, anyone?
Homogeneous.
Is it homogeneous or linear?
Linear.
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 Okay, it is linear. When you will take y is equals to vx, you will find that it is not homogeneous. Okay, so it is linear. It is in the form dy dx plus py is equals to q. Clearly we can see our p. Okay, so in linear differential equation we have to write the integrating factor first. Okay, so let's take it out. In e to the power this p dx, our p is 2x square plus 11x plus 13 over x cube plus 6x square plus 11x plus 6 dx. Now we will focus completely on finding the integration first. Okay, so what can be done for this integral? Can we factorize numerator? Can we factorize denominator as well? So let's check it. Can we factorize numerator or maybe the denominator? See, the denominator is a cubic expression. Okay, you can call it cubic polynomial. So if we are having cubic polynomial, how to do the factorization? So one way for doing the factorization is directly you will be getting the formula, that is x plus y whole cube's formula. Directly you will be able to see. But when we are observing it carefully, we can see clearly this is not a formula. Okay, we won't be able to write it in a compact form by using the formula. So we have to think about another approach. Another approach for dealing with cubic expression, cubic polynomial is you have to check what is that x value which will make this expression completely zero. Okay, x equals to 1 or maybe x equals to -1 or maybe x equals to 2 or maybe x equals to -2. Which number, when we will substitute over here, the complete expression will be 0. Okay, that way we will end up getting one of the factor. Okay, so for dealing with cubic polynomial there are two ways. The first way is directly you will be getting the formula, which is really simple, but the other way is not that simple. Okay, here you have to check what is the zero of this polynomial. That means what is that particular x value, which when we will drop it over here, we will substitute over here, the complete expression will be 0. And this process is tedious. Okay, it is time taking. It is always, it is not possible to figure it out what number we can take, because randomly you are taking x. You can think about x as a 1, x as a 2, okay, -1, -2, but how much? Okay, how many numbers you will be taking? 3, 4, 5, 6, 20, 30, 40, 50. It can be anything. It can be anything. So basically we will be checking like 1, 2, okay, -1, -2, 3, max to max 3 will be checking. If not, if it is not possible to do the factorization, either we must leave this question or we must think about another approach for solving this question, because this is trial and error method. This is not possible here. It is not possible to take so many numbers and waste our time getting it.
Yes, ma'am.
Okay, so
Yes.
we will be taking few numbers, 1, -1, 2, -2, and we'll be checking. I can clearly see all are positive. 1 I'm not going to take, and not also 2, because you can see all are positive and we want 0. Okay, once we will drop the substitute x value, we want 0. Okay, that way we will be able to figure it out, any of the factor. So 1 and 2 I'm not going to check. -1, yeah, I can check. So -1, if we'll be taking, this will be -1. If I'll be taking -1, this will be +6. This way you have to do quick. This will be -11 and this will be +6, right? Now we can say 6 and 6 is 12, +12, and -11, -1, -12. And yeah, -1 is making everything 0. Yes or no?
Yes, ma'am.
Okay, so when the question is given to you, most of the time it will be given in such a way that you will be able to figure it out. Okay, from this few numbers there will be a number which will make the expression, the polynomial, 0. So x value we have taken -1, and this complete expression became 0. The polynomial became 0. So we can say x plus 1 is one of the factor. Is it making sense?
Yes, ma'am.
Yes, ma'am.
Now do you know how to do the division? This division, have you learned anytime? X cube plus 6x square plus 11x plus 6, the division of the polynomials, have you learned?
Yes,
Yes,
ma'am.
ma'am.
Okay, so if you have learned this way, it is really simple. Okay, we have figured it out that one of the factor is x plus 1, another factor we are searching, so that we will be able to get by doing the division. Think about it. If you are having a number, let's say 100, okay, and you know one of the factor is 2 into something is 100, so you can divide 100 by 2. Okay, you will be getting 50, and now you are able to see this quotient 50 is the other number. Yes or no?
Yes, ma'am.
Okay, it is making sense, right? So let's do it same way. We are going to divide this 2 and we will be getting the quotient. That quotient will be the other factor. Okay, this is how we will be able to do the factorization. And after doing the factorization, partial fraction decomposition also we can try, right? Right, maybe. Let's see. X and x cube. So what should be multiplied with x to get x cube? X square, right?
Yes,
So x cube plus just x square. Then subtraction, this sign with here minus, this gone, and here we are having plus 6x square minus x square, that means 5x square plus 11x plus 6. Now here x is there, here we are having 5x square, so plus 5x we'll be writing. Okay, so we are getting plus 5x square plus 5x. Is it making sense, Meera and Upasna?
ma'am. Yes,
Yes,
ma'am.
ma'am.
Okay, minus, this is gone. 11 minus 5 is 6. 6x plus 6. So plus 6 we will be taking and we are done. We can see completely it is just remainder we are getting 0. Yeah, remainder must be 0 because we are saying that x plus 1 is a factor. Okay, so remainder must be 0 and we are getting that. The other factor we have figured it out, that is x square plus 5x plus 6. Okay, I'm rubbing these all the thing from here and I'm going to write x square plus 5x plus 6. So this is how we can deal with cubic polynomial when we are trying to do the factorization. Okay, this is another approach for doing the factorization. First, we will find what is the 0, and with the help of 0, we'll be able to figure out the other factor, like one of the factor, and then we can do the division to get the other factor. Now we can clearly see this is splitting the middle term we can use over here. So it will be x square, 2, 3 times 6, so 2x plus 3x plus 6. So we'll be getting x plus 2 and x plus 3. Is it okay, Meera and Upasna?
Yes, ma'am.
Yes, ma'am.
Okay, so basically what we did, quick, we are doing the factorization. Okay, for doing the integration, we realize that if we will do the factorization, then partial fraction decomposition, we can think about that. Okay, so we ended up getting x plus 1, x plus 2, x plus 3 in the denominator, and numerator for now we are keeping as it is, because if we are thinking about partial fraction decomposition, then we understand numerator. Okay, even if we are not doing the factorization, it is fine. So basically for now we are just focusing on this integration, e to the power. Okay, this is there, but let's find what will be there after the integration. So 2x square plus 11x plus 13 by this x plus 1, x plus 2, x plus 3. See, whatever way you do partial fraction decomposition, okay, like I'm also going to follow the same process, but little bit here and there while comparing or anything, finding a value. Okay, just your value and my value has to be same. Don't get confused at last moment. So we'll be having basically a by x plus 1 plus b by x plus 2 plus c by x plus 3. Yes or no?
Yes, ma'am.
Yes.
Okay, now both the denominator will vanish and we'll be having 2x square 11x plus 13, and here we'll be having a multiplied with x plus 2, x plus 3. Okay, then b multiplied with x plus 1, x plus 3, and then c multiplied with x plus 1, x plus 2. Now I am going to compare the coefficients of x square x, okay, and the constant, like, yeah, constant on both sides. You can do your way. Basically, your a value, b value, c value, and my, like, which way you have learned. You put x as a 0, x as a 1, like that you have learned, or by doing the comparison. Yes, anyone?
Both way we have done, ma'am.
Both is okay. So I'm saying x square's coefficient is 2 over here, and here x square coefficient is a. Okay, then b, then c. Is it okay?
Yes.
Yes, ma'am.
Coefficient of x is 11 over there. Coefficient of x will be, here we'll be getting x square plus 3x plus 2x. Okay, so 5x. So 5a we will be getting from here. Okay, from there we will be getting x square plus 3x plus x, so 4x will be getting, so plus 4b, and from here we'll be getting x square plus 2x plus x, that means 3x, so plus 3c. Okay, and the constant term if we will compare, so again we will be getting an equation abc. So basically at first we have to focus on finding abc. Let me check the integration. After that, will it be simple? Then I will leave it, because ABC you will be able to find it by yourself as well. Okay. Okay, let's find ABC. So here constant, here 6a, here 3b, and here 2c. Okay, now we have to find the value. So we can say that a is equals to 2 minus b minus c. Okay, or we can solve, like, please solve these equations and tell me what is a, what is b, what is c now. Please do it. A is equals to 2, I got. Okay. Now B and C we have to find. So we can say the first equation is B plus C is equals to 0. Okay, because A is 2. And the second equation is A is 2. So 5 2 times 10. That side 1. So 4B plus 3C is 1. Okay. So we are having this two equations. We can take 4B, 4C, 0. So this 2 gone. 4C minus 3C is just C. And we are subtracting. So 0 minus 1. C is negative 1. Okay, A is 2, C is negative 1. A is 2, C is negative 1. B we are supposed to find. So 2 minus 1 is just 1 plus 1. And that side, if we will shift it, we'll be getting B value, we are getting 1. Okay. So we ended up getting ABC. Okay. Let me write it over here. A is 2, B is 1, C is minus 1. Okay. So this is what we have to do the integration of this, right? Meera and Upasna?
Yes, ma'am.
Yes, ma'am.
Okay, so log of this, log of that, log of this will be getting. So from here, we are going to get after integration 2 log of x plus 1. Okay, plus log of x plus 2 minus log of x plus 3. Yeah, plus 3. So e to the power this all log log log. Now if we will use the property of logarithm, okay, we can say that let's take this 2 in the power in the exponent. So we will be getting this 2 as a exponent. So m plus n can be written as m into n. So can we write it as a x plus 1 square into x plus 2 by x plus 3? Is it making sense?
Yes, ma'am.
Yes, ma'am.
We are just using the property of logarithm. Okay, this is what we are having. Log of this. Okay, e to the power is there. So basically we are just left with this one. Okay, x plus 1 square, x plus 2 by x plus 3. Let me check our q. Okay, when we will do the multiplication with q, the other side, and when we will integrate, will it be simple? Then I will leave it. We are having x plus 2 square, then no, x plus 1 square, x plus 2 by x plus 3. So x plus 1 square, x plus 2 by x plus 3. We can clearly see x plus 3 gone. This one gone. And we are left with x plus 1, x plus 2. Yeah, doing integration is not a big deal. We can open the bracket and we can do the integration. This part by part. Right? X squares integration, then 3x integration, then 2 integration. Yeah, you'll be able to do. Got it?
Yes, ma'am.
Yes, ma'am.
Okay, let's leave it. So this question was really simple. Here the catch was doing the factorization of the denominator. Okay, and that you must have learned in your previous class, maybe in class 10. Okay, so anything from anywhere can be used over here. Now the next question, suppose we are having x dy is equals to x square plus y square plus y dx. Okay, here what we are supposed to find again. Okay, when x is 1, y is 0, then okay, when x is 2, find the y. That is how the question is asked. Let's find the solution first for this differential equation. So please check it. Is it linear or homogeneous? First, we will check homogeneity.
Homogeneous.
It is homogeneous. Let's Vx, if we will take dy dx is equals to this all plus y by x. Yeah. Okay, if we see root is there and the numerators exponent denominators the highest power, that is same. Okay, so we can say that it is homogeneous. Let's solve it. For homogeneous, we take y is equals to vx. That means dy dx is equals to v plus x dv dx. Here we'll be having v plus x dv dx. Now under root x square plus v square x square plus vx over x. We can clearly see x square will be common and x will come out. Then we can take x common. So in numerator, we are just left with, wait, no, the root will also be there. We are left with 1 plus v square by just 1, nothing. Right? Right? Any
Yes,
confusion?
ma'am.
Okay, let's proceed. So then we can take this v to this side. So we will be just left with this v will come to this side minus v gone. We are just left with 1 plus v square. And now this is very simple. dv by under root 1 plus v square. We can use the formula a square under root a square plus x square, right?
Yes, ma'am.
Yes, so yeah, you will be able to continue from here. The other, yeah, okay, you will be able to do from here. Let's do the next one. Suppose we are having the differential equation as this sine square 2x dy dx plus 8 sine square 2x plus 2 sine 4x y is equals to 2 e to the power minus 4x 2 sine 2x plus cos 2x. Okay, here also we have to, like, one of the condition is given that y of pi by 4 is this, then find y of pi by 6. So basically, let's do it. Let's find the solution first. So we are having sine square x dy dx. This is what we are having. It seems like we'll be able to, okay, this is linear in form. When we will do the division with sine square x on both sides, we will be getting a format that is 8 sine square 2x plus 2 sine 4x over sine square 2x y is equals to this 2 e to the power minus 4x. Okay, 2 sine 2x, maybe while doing the integration. Okay, so many sine, cos, e to the power, everything is there. Let's see what are we going to get. We'll be having sine square 2x. Okay, let me check the power of sine. I have taken it correctly or not. So the first one, sine square 2x dy dx, then 8 sine square 2x, 2 sine 4x. Then the other side, we are having 2 sine 2x cos 2x. Yeah. So yes, this is what we are having in hand. Okay. We can clearly see this is our P, right? Right?
Yes, ma'am.
Yes,
Okay.
ma'am.
E to the power P dx. Let's do. So our P is this one. 8 sine square 2x plus 2 sine 4x. If we will separate the terms, okay, the first term in the numerator by the denominator, we will be getting just 8. Okay, because we can see sine square 2x, sine square 2x is cancelling out each other. So we will be getting just 8 for the first term. Okay, and what about the next term? We are having 2 sine 4x in the numerator and sine square 2x in the denominator. So see, 2 sine 4x by sine square 2x we are having. Let's try like just expanding the numerator, the double angle formula. So can we write it as a 2 into 2? sine 2x cos 2x can be this one as this one.
Yes.
We can write it. Okay, why we are doing so? Because in denominator we can see there is a sine 2x. Okay, so one of the sine gone. We are left with 4 in the numerator, cos 2x in the numerator, and by sine 2x in the denominator, which is just 4 cos by sine cot 2x, right?
Yes,
let's
ma'am.
let's take it. So I'm going to write it directly over here. Cot 2x we are having. Okay, these all the steps is giving us cot. And do we know integration of cot? Can you tell me what is integration of cot? Yes, Meera and Upasna.
Log sin x.
Yes, log of sine x. Okay, sine x. Since we don't have x over here, we have 2x. Okay, so while doing the integration, we can take the derivative of 2x in the denominator. Do you know that? Do you know that? Okay, we can take the derivative of 2x in the denominator while doing integration. Why we are doing so? Actually, this is the same like the substitution only. You are just substituting 2x as a t, and then you will be getting dx. Okay, 2 dx is equals to dt by 2. So that 2 we are writing in the denominator. Okay, we do it just directly as well. So this is what we are having after the integration, and we can clearly see that always, most of the time, okay, 70%, 75% of the time, we are able to it. Just remove this e from here, but not in this question. Okay, we can clearly see 8x is there added in front. So what to do with that? So if we will try just simplifying it a bit, we can write it as a e to the power 8x into e to the power this 4 by 2 times 4. So basically 2 log of sine 2x, right?
Yes,
Right?
ma'am.
We can write it as a e to the power 8x, and this is square will be there. So basically we are having here sine 2x whole square. Okay, so this is what we are having for now. Now we will be multiplying with the integrating factor, left side, right side. So left side is fine, right side, let's check that what will be there in the integration. So basically we are having sine square 2x, okay, with e to the power 8x. Let's multiply. So we were having 2 e to the power minus 4x. Let me take the question. So basically here q we need to multiply. So our q was this 2 e to the power minus 4x 2 sine 2x plus cos 2x, and that we are going to multiply with this one, that is e to the power 8x sine square 2x, right? Right?
Yes.
Okay, y into integrating factor we are having over here. So this is what we are having. Let's check the integration. So we can clearly see here e to the power minus 4x, here e to the power 8x. Let's take it at first. So we will be having 8x minus 4x is e to the power 4x. 2 I am keeping out. And we are having sine square 2x. Okay. We are having sine square 2x. And in bracket, we are having 2 sine 2x cos 2x. dx. Okay, let's check what can be done. If we will introduce just this sign in the bracket, okay, what are we going to get? E to the power 4x, sign in the bracket will be, okay, we'll be having 2 sine 2x, that's cube, okay, plus Nothing is cancelling out. Just a second. Something must get cancelled out. Oh yeah, this was Q. This was Q. What I have written, 2e to the power minus 4x, 2 sine 2x, cos 2x. Yeah, by I have not taken the denominator. Sine square 2x. Sine square 2x, sine square 2x. Okay, great. So we were confused that now cube and everything we were getting. Now you can clearly see that we are just having e to the power 4x. We are having 2 sine 2x, 2 sine 2x, cos 2x, right? Right?
Yes,
Now
ma'am.
I will be checking. Okay, one day I was telling you that there is a rule that if you are having integration of e to the power x, okay, a function f of x plus f dash x dx, that's integration. If you are having directly, the answer will be e to the power f, e to the power x, f of x plus c, right?
Yes.
Okay, so I'm going to check because sine is there. Great. Cos is also there. Okay, so it seems like we will be able to create the pattern, but this 2x, 4x. Okay, let's check first. For now, let me take this 4x as a t. Okay, so that I can write e to the power t. Okay, so 4 dx is equals to dt. So this will be just t. Okay, I mean, this will be just t. Okay, at the place of dx, we can write dt by 4. So this 4 will come. And this 2x. Just a moment. Yeah. Can you see? Is it making sense?
Yes, ma'am.
Okay, so we are able to arrange it in that format. Okay, if I am taking this 2 sine t by 2 as a f of x, okay, that means f of t. We are getting f dash t as a this one. Okay, dt. We know the integration of this will be nothing but just e to the power t ft. Our ft is this 2 sine t by 2. Okay, e to the power t, and outside 1 by 2 was there, and we are done. Clear?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
how we'll be doing it. Let's take few more questions. If we are having dy dx plus 1 by x square minus 1, y is equals to, again, okay, clearly I can see this question. Again, we are having a linear, yeah, a linear differential equation. Okay, so we will be able to do it by finding the integrating factor. Let's take another question. Next question is the slope of the tangent to the curve Okay, this is the slope of the tangent, and then it is given that if C passes through a point, a point is given. Okay, this and another point is also given. Then we are supposed to find a value. So let's see what the question says. The slope of the tangent to a curve C. Okay, y is equals to yx at any point is this one. So basically the question is trying to say that this is the slope of the tangent, right? This is the slope of the tangent, right? So can we say this is dy dx?
Yes, ma'am.
Yes.
We can say that. Okay, it's just written in a statement form. Every time in all the question it's given directly that dy dx is equals to this, dy dx is equals to that. But here it's written in the statement form. So what? Okay, we are understanding that the slope of the tangent means dy dx is given to us. Now we are having dy dx is equals to this one. Okay, and we will check now what to do. Is it homogeneous? Is it linear? Is it is what? Okay, it is variable separable or what? Okay, so let's check what can be done over here. So these all are x. Basically, we can. It looks like variable separable, right? Right. We don't have to do anything over here. Just we can take the integration of this side, integration of that side, and we will be able to find the solution if this integration is possible, right?
Yes.
Okay, we can see all our x. Okay, so we don't even have to separate, it is already separated. Okay, so this is what we are getting now. If we will focus on this integration, let's see what can be done over here for doing the integration of this one. So at first, if we will take e to the power x as t, wait, I will take e to the power x as a t, but for now, are you noticing that this is and this one? Okay, here if we will try simplifying it a bit, we can write it as 2 plus 9 by e to the power 2x, yes or no?
Yes, ma'am.
Yes.
Which is nothing but e to the power 2x is the LCM, and we are having 2 e to the power 2x plus 9. So this term in the numerator and the last term together will come, and the denominator this one. Okay, it is sorted already, but again we are having e to the power minus x and all. We will see what can be done. So for now, I am going to write it this way. See, we are having 2 e to the power x, I mean 2x, plus 9 over the denominator, whatever we were having, this, plus no, minus 6 e to the power minus x by 2 plus, or directly we could have written this 2 plus 9 e to the power 2x as a, let me write it directly, okay? If it will create confusion or we will not be able to do the integration, the other one, okay, then we will write it as it is. Let me write it for now. So I'm going to write the denominator as this one, okay? If we will write the denominator as this one, this e to the power 2x will come on the top, right? Right.
Yes, ma'am.
Yes.
Okay, and we will be having it, this 2 e to the power 2x minus 6 e to the power minus x plus 9 over this 2 e to the power 2x plus 9. Okay, just little bit simplification we have done in the denominator, nothing else. Okay, this is what we are having. Let's check what can be done. So we wanted to take this term and this term together. Let's take it. So e to the power 2x will be there, and 2 e to the power 2x plus 9 together. The same 2 e to the power 2x plus 9 in the denominator dx minus 6. This e to the power 2x, this multiplied with e to the power minus x. Yeah, still we are having e to the power 2x plus 9. The first part we are already having just e to the power 2x. Okay, if we will do the integration, we understand that it will be just e to the power 2x by 2, right? Right.
Yes.
The
Yes.
other one, the numerator will be e to the power 2x it, into e to the power minus x. That means e to the power just x. Okay, and the denominator is 2 e to the power 2x plus 9. Now if I will take e to the power x as a t, that means e to the power x dx is equals to dt for the other one. So we can see this dt we are getting over here, and this we have taken t, so this is 2t square plus 9, right? Right. Any
Yes.
confusion?
Yes.
Now from here, okay, x square plus a square format, if we are trying to generate, okay, tan inverse formula, we can take out 2 common, okay? So 6 by 2, we can write this is nothing but this t square plus 9 by 2, okay, which can be written as root 3, no, just 3 by root 2 whole square, right?
Yes, ma'am.
Right. So yeah, you will be able to continue from here. Any confusion?
No, ma'am.
Okay. So yeah, let's take another question. Here it says find the maximum value if dy dx plus 2y tan x is equals to sin x, and okay, x lying in between 0 to pi by 2. Okay, then, and one condition is also given over here. Y of pi by 3 is equals to 0. Then the maximum value of f of x, I mean y of x. This we have to find. Okay, so this question, you You can see clearly, you must have solved this type of question, e to the power, finding the integrating factor, and the p. Okay, you can see this p is also known, right?
Yes.
Right. Okay, please do it. No, just give me a moment. Please do it. Okay, you will be just doing the finding the integrating factor. Just find it till there, integrating factor. Okay, just a moment. Yeah, what you got as an integrating factor?
Sec square x.
Okay, just sec square x. So now we'll be finding the solution. It will be y into, since we have to find the maximum value, let's check how we are getting the function. So y multiplied with integrating factor, that is sec square x, okay, is equals to integration of sin x into sec square x, okay, plus c. So let's continue. Sin x into sec square x will be, okay, 1 by cos square x, sin by cos is tan, and tan into sec we are getting, right? Yes or no?
Yes, ma'am.
Yes, ma'am.
Integration of tan x sec x is, yes, yes. Is it sec x? Is it sec x? Right? Yes, Meera and Upasna. If sec square x is there, the integration is just tan x, right?
Yes, ma'am.
Okay, we are doing antiderivative. So have you seen the derivative of sec x is sec x tan x, right?
Yes, ma'am.
Okay, so we are having over here, it will be just sec x plus c. Here we are having y sec square x. Now we are trying to find the solution. So here the condition is given to us that y of pi by 3 is 0. Okay, so y of pi by 3 is 0. Let's substitute it over here. So this side 0, okay, because y is there. Here sec x, that means sec pi by 3 plus c, right? That means c is, what is
Yes,
the value for sec pi by 3? Is it just 2? Yes.
yes, ma'am.
Two
Okay.
marks.
So this is what we are getting. We are getting y sec square x is equals to sec x plus 2. We can just take the sec square x to this side. So we will be having 1 by sec x over here plus 2 by sec square x. Okay. So we can write it as a, this is y. Okay. Cos x, and this one will be just 2 cos square x. Let me check. Here integrating factor you have got sec x square, yeah. Log of tan, like tan x is log of sec x, and that this power will go. But the other side we were having sin x, then we got tan into sec.
Ma'am, C is -2, right?
Just a moment. Oh yeah, c is -2. And this was sin x, right? This was sin x? No, this was sec x. Just a moment, no, let me check this way. If we will take cos x common, we'll be able to get 1 plus 2 cos x. Yeah, we can find the maximum. Okay, but I'm checking if everything is okay or not. Yeah, it's fine. Okay, let's continue. So this is our function. Okay, we have to check at which point the function is maximum. What is that x value where we'll be having the maxima over here, right? Right?
Yes.
Yes,
Okay, and
ma'am.
maxima and minima, you know how to check it. Okay, we will be checking the critical point, and then we will be finding the critical point, and we'll be checking is that a point of maxima. You can do basically double derivative. Okay, that will be the easiest over here. You can do double derivative chain rule already you are having. You can check that is the point of maxima or not, and then you can say that yeah, this is the value which is the maxima for this one. Any confusion over here? No, right? Maxima you
No, ma'am.
understand. Let's continue. Now one of the question is like this: dy dx plus x over x square minus 1 phi is equals to x to the power 4 plus 2x by under root 1 minus x square. Please find the integrating factor over here. P, clearly we can see what is our P. Okay, find the integrating factor.
Ma'am, is it root x square minus 1?
Here, this one,
No, ma'am, the integrating factor, root x square
the,
minus 1.
okay. So integrating factor, you are getting root x square minus 1. Yeah, okay. We'll be getting integrating factor as a, you must have done the substitution this one, and you are getting the numerator, and then doing integration is really simple over here, right?
Yes, ma'am.
Yeah. Okay, that way only we need to do it. Let's take another question. We are having x minus y square dx plus y 5x plus y square dy is equals to 0. Okay, we have to find the solution of this differential equation. Okay, if we will try arranging it, we have to check, is it variable separable, is it homogeneous, is it linear, it's what. Okay, let's check it. So if we will separate this dy, first let me write this dy. If we are keeping on this side, that means this 5x plus y square multiplied with y, this one. Okay, and dx if we are shifting to another side, so minus of x minus y square dx. Okay, we are checking that which differential equation, which type we are having in hand. Okay, so variable separable, we can see it's not possible over here. Okay, we will check, is it homogeneous or what. So dy dx is equals to, we can write it as a y square minus x over here, and we can write it as a y 5x plus y square over here. Yeah, but we can see the power in the numerator and the power in the denominator, it's not same, right? Can you see the max highest power, the degree? Okay, so it doesn't looks like homogeneous. If we will take, just a moment now. See, at first it was not homogeneous. Okay, we have checked the highest power in the new, like highest power in the numerator, highest power in the denominator, that was not same, and we realized that it is not homogeneous. It is not variable separable as well, because if you will try just separating the variables, you won't be able to, okay, take all the y's together, all the x together. You won't be able to take it. You can clearly see 5xy we are having over here. Okay, in numerator we can take x, okay, together, but the denominator one. So see, I have taken for now this y on the other side, this y. Okay, and here I have kept everything as it is, y square minus x and 5x plus y square. Now, if we will take the assumption that's, for now, let's say this y square is u. So basically, 2y dy is equals to du, right?
Yes, ma'am.
Okay, that means y dy is du by 2. Now, at the place of y dy here, I'm just substituting du by 2, and wherever y square is there, that there I am writing u. Okay, so you can see clearly y square, at the place of that I have dropped u. Okay, minus x in the denominator 5x, and at the place of y square I have dropped u. Now can you see how beautifully it has taken the shape of this is homogeneous? Yes or no?
Yes, ma'am.
Okay, now we'll be able to solve it. We can take, now you can take v or maybe t, whatever you want. So you can take this u is equals to vx. Okay, vx, don't get confused between u and v. Okay, this u is vx, so we can take this vx over here minus x over 5x plus vx. If u is vx, then du dx is v plus x dv dx. This is v plus x dv dx, and 1 by 2 I'm just keeping aside for a while, this way. Okay, so this is what we are having. Okay, now this 1 by 2 you can take to this side, you can write 2 over here. Okay, so this v will come to this side, so we are having 2 vx minus x, and this v will come over here over 5. Okay, why I'm not canceling this x and x first? So we will cancel out x and x, and then we will be able to do it, right?
Yes.
Yes, ma'am.
Let's take another question. One of the differential equation looks like this: dy dx is equals to ax minus by plus a over bx plus cy plus a. Please check it. Okay, we can do it by using the variable separable. The like, is it variable separable, homogeneous? Okay, I'm not going to say it is linear because it is not. Okay, please check it. If we are checking it is for homogeneous, you can think about this. If you will take y is equals to vx, then you can, you see, due to this a we are not able to take out x common, right?
Yes, ma'am.
Okay, so this is not homogeneous. We can say this is due to this a and a, numerator and denominator both are a, or one of them is b. Just a moment. No, both are a. It is not. Okay, homogeneous it is not. So we will check, is it variable separable? So we will take it like this: bx, okay, dy plus cy dy plus a dy is equals to ax dx minus by dx plus a dx. Now it seems like we will be able to do this two together. We can take it. Just a moment. This one, and this one. Okay, if we will take it together, that means bx plus dy, bx plus by. Okay, dx. If we will do the integration, at least for this one, because others are, you can see, this one doing integration is not a big deal, this one doing integration is not a big deal, this one we can do it easily, and this one we can do it easily, right?
Yes, ma'am.
Okay, so only this one. So why am, just a moment now, it is bx dy plus by dx, it is that. So if we will take b common, it is x dy plus y dx. Have you encountered such situation earlier? Can we say it is derivative of xy? First function derivative and second function
Yes,
derivative
ma'am.
first. So basically we are going to get just xy from here, right? Right?
Yes, ma'am.
Yes.
Okay. So yeah, we are done. Others will be able to do it easily. Okay. And when we are talking about solution, then you will be able to find the solution. See, this chapter is really simple. Everything you already know. You just have to sit with the question, you have to solve it. If you will encounter question from here, please do solve it. Yeah, while matching the options, answer, just do the calculation, simplification carefully. And what about this one? If we are having a differential equation as dx dy is equals to tan inverse y minus x by 1 plus y square. Okay, how to do this one? Please check it. It is tan inverse y minus x by 1 plus y square. Yeah. Yes, this is what we are having, just this. Have you, so like, have you encountered such differential equation where the linear form is like this, dx dy plus p into x is equals to q? Have you seen such differential equation?
Yes, ma'am.
Yes, ma'am.
This one can be done like this. See, dx dy, okay, is equals to tan inverse y by 1 plus y square minus x by 1 plus y square. Now this one we will be taking to the other side. So we will be having dx dy plus x by 1 plus y square. So p is 1 by 1 plus y square. Okay. And q is this complete. Okay. If we have to do the integrating factor we will be finding. So e to the power p dx, please find integrating factor. Yes. What will be the integrating factor, Mira and Upasna?
E raised to tan inverse y.
Yeah. Okay. E raised to the power tan inverse y. Now we are having integrating factor. This one will be doing the multiplication with this one, and we will see what can be done for doing the integration. Right?
Yes, ma'am.
Right. Okay. So I believe substitution will work over here. Just tan inverse y you will take as a substitution as a t u whatever, and the denominator you will be getting, right? Right.
Yes,
Okay, so the integration, doing integration with this q, it's not a big deal. Let me take another question. Suppose we are having, we have to find the area bounded by the curve. Y is equals to mod of x minus 1 plus mod of x minus, no, this one we have done yesterday. Wait. Suppose we are having x minus 1 mod, that is smaller or equals to y, that is smaller or equals to 5 minus x square. Okay, let's see. What will be the area bounded by this curve? Just this curve. Okay, this all together, the inequalities. So the first one, let's focus on this one. Here you understand, Meera and Upasna, that at first, if we will be able to plot the figure correctly, okay, then area definitely we will be able to find. So let's draw the figure. So mod of x minus 1, okay, that is smaller or equals to y. If we are focusing on that at first, we can say we are just having y is equals to mod of x minus 1, right? Right?
Yes, ma'am.
We can redefine this function. Okay, we can say it will be when x is smaller than 1, it is minus of x minus 1. When x is bigger than 1, okay, it is bigger than or equals to 1, it is just x minus 1, right? Right?
Yes, ma'am.
Okay, and that day we were also discussing how to shift the graph. So here the graph will be mod x graph is this. Okay, mod of x minus 1. Okay, so I said that day that if inside function there is a addition subtraction, please take it this way, that x minus 1 is 0, x equals to 1, so the graph will shift 1 unit towards the right, right?
Yes, ma'am.
Okay, so this point will shift 1 unit towards the right. So now our graph is going to look like this. Okay, is it okay?
Yes,
Okay, and we understand how piecewise defined function we are having, that also we understand, graph also we are having. Okay, now the other one is this inequality. Y is smaller equals to 5 minus x square. That means we can write it as a y is just 5 minus x square, root of course. Okay, that means y square is equals to 5 minus x square. That means it looks like equation of circle, right? Right, x square plus y square is
Yes,
equals
ma'am.
to 5, right? It is equation of circle having radius as a root 5 and having the center as a origin, right, Meera and Upasna?
yes,
Yes, ma'am.
So this is how our circle will look like. Root 5 means uh see, we are having under root 4, okay, and then root 5, so root 4 is 2, root 5 means 2 point something, right? Right.
Yes, ma'am.
Okay, so 2 point something. So we can see 1, and if I'm saying this is 2, so yeah. Okay, this is how our circle will look like. Basically, it's not ellipse, it is circle. Okay, if let me check x greater or equals to 0, y greater or equals to 0, if that condition is given over here. So yeah, okay, it is also given over here that this 2 x and y. And yeah, since it is inside the root, okay, since it is inside the root, we must take that this the domain, okay, must be, this must be greater than or equals to 0, right?
Yes.
Okay, so this greater or equals to 5, okay, x, just greater or equals to plus minus root 5. So yeah, so basically this is the part we'll be having. this part and this line. Okay, since inequality is there, so let's check which is the area bounded by these two curves. Okay, you understand that we can take a test point. You can take a test point that is suppose 2 comma 0. Okay, and you can check in the first inequality, is it satisfying? So if we are taking 2 comma 0, okay, 2 minus 1 is just 1. Okay, and the other side is 0. 2 minus 1 is just 1. 1 is a smaller equals to 0. Is it so? Is it so?
No.
Right? So this is not the reason. Which one is not the reason? Okay, this is not the reason. Okay, it's not. Getting it?
Yes.
Yes, ma'am.
Okay, it's not the region. Similarly, other one will also, I believe it will not be the region. Okay, area bounded will be this region. Getting it?
Yes, ma'am.
Okay, and then we need to find the area. So are you understanding how we can work with the inequalities and we can plot the graph?
Yes, ma'am.
Okay, once you are done with plotting the graph area, you will be able to find. Okay, so yeah, this is how when the compound inequality is given, you can separate it and then